Hi, this is Richard Ma from QuantStamp, and this is Nathan and Poming, and we're Beacon Thugs in Harmony for EthDenver 2019. So this is our entry. So basically, we built an Ethereum 2.0 beacon chain simulator. So the idea of the beacon chain and Ethereum 2.0 is that you can actually scale transactions on Ethereum. And we actually built a full simulation of how it would work based on the latest specs. And this is actually very technically challenging work because most people don't understand all the intricacies and the documentation is not fully there. So we built both a backend, which is in Python, and also made a Python server that served the data to a React front end. And the benefit of this is that for new people who are getting into Ethereum 2.0, you can actually visualize how it works. So at the beginning, there's a RSA key generation ceremony, similar to the Zcash powers of tile ceremony. And then after that, this large number is used to calculate a verifiable delay function that produces unbiasable randomness for the beacon chain. So we basically visualize how this works and how the shards allocate block producers for every single new epoch. So you can actually go to beacon-chain.com and play with the interface. And you can go to the next step, you can go to the previous step, and you can also fast forward 5 steps. And it shows the hashing process and the secret revealing of the secret random numbers. So that's it for me. On to Nathan to show more about our backend simulator.
Yeah, so in our backend simulator, we have a Python script and server that does a entire faithful implementation of the algorithm that's used to generate the blocks on every shard and also generate the random seeds, the unbiasable random seeds that allow Ethereum 2.0 to provide randomness, select random validators with entropy that is entirely biasable. I can try and make it pick me every time. I will fail every time because of the verifiable delay function, which mathematically you just can't beat. It generates this randomness. It only requires 1 bit of randomness in that entire epoch, and then you can't have a clue what's going to come out of it. It's really quite amazing, but it's an incredibly dense spec with that you have to understand the entirety of the implementation to even start getting at the small pieces based on the documentation that's produced. This kind of a very granular debugger level of understanding that this tool can provide can really show exactly how it's implemented and allow us to train people to expand on the state of the art for this. And really this is the future of cryptocurrency, I believe.
So we actually built something which doesn't exist before, which is this interactive dashboard that anybody can play with. And we're really excited about Ethereum 2.0, and after really understanding the spec, we're actually even more excited than before because we're able to verify all the fundamentals of how you generate random numbers, how do you assign validators to shards, and how do the shards coordinate, and how does it prevent bad actors from producing blocks. So this is really exciting, and we're really happy to share this, and really appreciate all of you for watching, and thank you.